Hello, my name is Ian Vogelesang, and this is the video for Demo 0 All Discovered LUNs RAID. Let's go to the output folder and take a look. First of all, let's look at the IVScript program. We can see here that the program is the same as in Demo 0 for DF. We have the IP address of the host, and then we have the serial number of the subsystem. So the RAID subsystems have 6-digit serial numbers. This is an HM800, as we'll see. Okay. Then next what you can see is that since a command device was discovered, we have a folder that's got the RMLive API configuration information for this subsystem. And there's different types of information that you get that each go into their own CSV file. Let's go back up. But before we look at these files, I want to introduce the IV CSV File Loader, which is a little bit easier as we get into the more complex demos to load just the information that you want to look at after you run a test. The IV CSV File Loader is for HDS performance team members, located at /scripts/IV on the filer, and it's in the IV distribution archive for ITPD users. Let's go ahead and launch that spreadsheet tool. Then we're going to scroll down and select the output folder, which is on my desktop. And we just select the output folder for the test. We click OK. And then in this test, we've only retrieved the configuration of the test host. We haven't performed any tests. So the only CSV files that are available are the configuration CSV files. So let's make sure that we load whatever configuration files we get. Turn those all on and scroll down and click import. First, let's go and take a look at the IVScript program. Here we can see that the IV CSV File Loader loads each file into a tab, and it loads text files and it loads CSV files. The IVScript program is a text file, but regardless of whether it's a CSV file or whether it's a text file, since the tabs don't have enough characters to fully describe the path and the file name, that they have to be shortened if they're too long, at the very top of each tab there's a header that shows you the folder that this file came from and what the file name was of the file within that folder. There's a divider line, and then you see the content of the file below. So if we look at the available test configuration, available test config is a summary to help you see at a glance whether your test configuration is as you expected it. First of all, we can see the summary of the LDEVs by subsystem, by drive type, and here we can see there's LDEV 0 to 3 and that there's 4 of them. Then you can see the LDEVs by test host if you want to look to see if each host has the LDEVs that you expected it to have. And then you can also see the same information presented by subsystem port. In this case, we can see that this host sees all 4 LDEVs twice, once on port 3C and once on port 4C. Then we can see drive counts. We can see that for the FMD DC2 drive type, there were 8 drives in one RAID 5 7+1 parity group, and that there was a total of 8 drives overall in the test. What's very handy with IV is that since you have the subsystem configuration, and since you know exactly which drives of which types are behind all the host LDEVs, we can present some of the information by backend drive. And in particular, we can show you the queue depth, the host I/O average queue depth per backend drive. And this is important, for example, if you're doing an FMD test where you need to get the FMDs up to a queue depth of perhaps 128 per FMD before you can get the FMD up to its maximum IOPS. Similarly for disk drives, when you're doing random reads, the host average queue depth is spread evenly over all the back-end drives because each host I/O lasts for the length of a back-end drive I/O. And so either way, you can see the average host queue depth per drive. We compute the average queue depth using Little's law by multiplying the IOPS by the response time in seconds, and then we divide by the number of drives, and we can get the average host queue depth per back-end drive. And then the other thing that we can do is we can show host IOPS per drive. We can contrast the host IOPS with the subsystem reported IOPS. Okay. Oh, and we can see here that there's a command device that we're using. This is the command device we're using. It's the first one found that goes to this subsystem. Okay. Then if we look at available test LUNs, the available test LUNs have not only the attributes discovered by SCSI inquiry, but they've also been augmented with the attributes of the underlying LDEVs as discovered from a command device. And in particular, you can see, for example, for internal LDEVs, you can see the drive type. And take a look yourself here, and you can see there's many different things that you can select from. Any one of these attributes you can select from when you're creating a workload. Oh, we already looked at the IvyScript program. Oh, and then you can see the individual, you can see the cache memory size. It records various things about the subsystem. Here we can see the configuration of the array as viewed by rmlib. So this includes only the attributes discovered from the command device, and it's for the entire subsystem, not only the LUNs that the host can see, but also all LDEVs in the subsystem. What else? We can see the status of the MPUs. We can see what all of the ports are set to. We can see the rmlib version for the record. And then also here we can see, for example, we record the microcode version that this test was run with. So Ivy automatically records the kind of things that you're looking for to make a complete record of your test. Okay, well this is pretty much it for demo 0 RAID. Thank you.